Good afternoon, everybody. This is Brad Dyke reaching out to you. I am at a place where I decided I had this old Isilon platform here, and when I bought it, I wanted the SAS bridges in it, a few other the subcomponents, and of course this is the 6 gig SAS bridge cabling, and of course it has a huge number of discs in the front, and it's got discs in the back down here in the lower tray, but no motherboard. So I decided, you know what, I just cannot allow this chassis to go on without its proper motherboard. So that's what this is about, the motherboard. In this case, we are looking specifically at the SuperMicro X8 I think it's T6 Alpha, but actually it's not a dash alpha, it is a dash F. So we'll go over this motherboard real quick. Now what this motherboard is, it's actually the SuperMicro OEM board, which is actually, like I said, is a Series F, which has the high performance SAS tiering and can do quite a few actual HBA based disks for connectivity. Plus it's got the type 2 PCIe 8X slots on board. You've got the separate bus here and then a new bus here, and of course there's the break in the middle. You have external USB outputs for internal boot devices, USB 2.0, so it's pretty sluggish. Then you've got your SATA, which is tiered, and of course your interfaces, your chipsets. Two of the 5500 or 5600 Xeon processors, those are the 1366 base, which are on order and are coming, so you'll see that down the road. The power supply interface with the split support power supply. Of course, our normal fan outputs and our 12 slots of DDR3 memory. Now, with this being said, also up here at the top, you see the two 1 gigers serial USB and PS2. But also, I'll be contemplating putting in a 10 gig fiber bridge card and also a HBA-based channel control interface, as well as a USB 3.0 adapted card, low profile. I may or may not do that. I'm not positive what I'm going to do. The other option is I can put in a SATA, eSATA external connector and connect up my iStock interfaces for long-term archiving on slower disk. So with that being said, the tier constructs of this motherboard are two split 64-bit buses for 128-bit architectural full duplexing for bus transfer rates, which will give you about 15, maybe 16 terabytes of bandwidth. Now we're going to look at the case itself, the work I'm doing on it itself. You've got dual power supply outputs, which I will run only with one. It is not a shared based power output, it's just a redundancy output. I use that because I'm a poor man and I can't afford to run all that firepower and run the risk of frying both power supply outputs. You've got the OEM manufacturer's templated backplating. There's no insert or exert. It is what it is. We have what's called a low I/O shield for airflow, which goes right there. And of course the cross support beam, which goes across. So this is what it looks like when the motherboard would be fully mounted into the case housing. Now, with that being said, in the back, as you can see, there is hidden inside are the discs themselves. Hang on a second, let me take this off. Okay, so I've taken the plate off, and here in the back you can see basically multiple discs sitting in here ready for use. And then in the front, the same setup. You know, there's quite a bit of spinning disc here, so when you pop one of these out, you'll actually see the discs that are mounted. And it gives you a resource, but the question is, what kind of resource are you really going to do? In this case, probably just strictly 2 terabytes or better in my suggestion. And way down there in the bottom, as you can see, are the SAS paired and set cabling, which is not the same as the cables that plug into the motherboard over here. They are actually going way down deep into a bus board, you can see down there. And those bus boards will then synchronize, like very much like a SCSI ID synchronization, these groupings of disks on the front and the back to basically two principal channels. Those channels will come out here. And this also comes with what's called as a floating SSD adaptive bridge card. This is part of the EMC proprietary nature of this EMC Isilon platform. And they would put a small, very low-based boot PROM on this card, and that would post this device as a SATA device up and operational in regards to what it's doing. It's got the power outputs here and more. But basically, in a nutshell, it is really not necessary. I can actually bypass that altogether, and I can boot off of a principal instead. Now, with the principal being done, the key thing about doing this kind of a PROM boot process is that I want to make sure that when I choose, probably TrueNAS is what I'll use to run this array, just initially. I may flip it over to Microsoft and use an ISA service, but in general, probably TrueNAS is what I'll work with initially on this to provide me an archiver, because I have another Isilon over here, which I'm pretty sure I'm going to retire, but it's got 6 terabyte drives in it, 2 terabyte drives, and so on, but the format is antiquated. The actual SP5000LP motherboard, that's an OEM Intel motherboard, is really old. And so I think I'm going to take these guys out and look at maybe selling this guy as a availability device for somebody who's looking for a baseline NAS that they can play with. So, with that being said, I'm still waiting on the heat sinks and the CPUs. When they come in, I'll continue this video. But this is the beginning, and for now, I'll let you go. Bye-bye. Okay, so as you remembered, we had these 5620 processors in earlier, and I was using an out-of-spec RAM spec, which is the DDR3 2400, but it posted, and it did work, but this is not really the kind of RAM that will either fit in here because it's too high because of the heatsink, and two, it's not within spec. So for now, I'm going to remove that memory and get that out of the equation as well. And it's good memory. It's more for a PC than it is for a server. But it was used for my diagnostic states, so I have no complaints. Now, here I have the new X8670 series 95 watt processors. Oddly enough, though, this one doesn't have much Intel information on them, which may mean that they're an OEM rebrand or an open brand. My counterpart in Denmark is dealing with, I believe, an X5679, which is also very similar. They really don't carry much information at all on board, but all in all, they're good chips. So I had to wait for them to come in, and I've got them in now. And I got the post-SATA board in as well. And principally, I've already booted this up and used a USB drive, 2 USB drives, one for OS load and one for OS boot. And you know, all the components tested well on this, and so that way it would be in good shape. I also secured myself 6 ECC RAM registers. Pulled out the fan assembly because there's something going on the fan assembly. They're posting as red on the alert status. So I'm going to check more into that and see what's going on. They shouldn't do that, but that's fairly easy to address. Most likely it's because one of these fans are starting to fail. But the key detail about that is, of course, that the system is taking the fans well, and there might be an oxidization issue going on with the connectors, but they blow pretty hard right now, and got to find out what diagnostic state is causing some of that to happen. But it's not a showstopper. You know, sometimes they just run at full speed. Now, the other thing I got from SuperMicro was the heat sinks, which are right here. And this is their anchor board. But as you can see on the motherboard, this is a SuperMicro motherboard as well, and it has its anchor boards in place already. Now, my only heartache I have right now is, should I do the industry silicon dioxide tape, or should I go hardcore what do they call it? Paste. Cooling paste. I don't know yet. I think I'm going to start them off first and monitor the temperatures, and if I don't like it, I'll just shave this stuff off and put liquid in its place and take it from there. This is definitely better than my temporary heat sinks, which do work, and they work pretty well. It's just that they were temporary and for a lower processor speed footprint. But no complaints on my side. So I'm going to be building this out, putting the new heat sinks in place, making sure that everything's working correctly. And one of the reasons why I said that I cannot use the RAM in the way it was set up, as I'll show you. So here's the key difference between these. Now first, this RAM is basic DDR core memory. No ECC mode, no register state. But also, it's kind of big. So when you look at it, it's a lot taller. So if that memory is in place, then the error control field component, which is this, cannot fit correctly in its place. It is pushed out and up away from the motherboard when it needs to be a close fit. So you have to follow the compliancy requirement of the RAM so that it will properly fit. I'll give you an example here in just a second. So here we have the heat sinks temporarily in place, and then we can put our fitter shield, which is basically an air control device designed to keep the air in the right place, and that allows it to fit like that. And it's clearing, so that means the lid will close on it and help also to control the airflow, as well as allow you to put the crossbar section that is used to support this, and that basically is this crossbar section. You do need it because it helps stabilize the cross section of the server so it doesn't bend or twist and run the risk of damaging something locally. So with that being shown, my next goal is to continue to address the SAS interface issue that's going on. It's not coming up quite right, and I think that's a little bit off for some reason. I want to make sure that we can tackle that and get that addressed. So those will be the next two big things. One, finish the processors, put all the new memory in it, clean up my old processors and put them away in my CPU collection. But I will also, and I've already used it already, if you're not familiar with this, is I've used this Arctic Clean thermal material cleaner. It comes with 2 jars, 1 and 2. Really great little thing, along with Arctic Silver or the Deep Cool thermal paste, which is also valuable. That allows us to clean the processors. It's important to get the surface area totally clean. No grease, no oil, no nothing, because those do affect the cooling processes of the CPUs, or any processor that might have a heatsink on it. But that will be our next step. Hello everybody. Now we're on our third part of the equation when dealing with the NL400 Isilon platform. I have inserted it back into the rack, staged the disks. There are 36 disks that are active here, as well as the SSD extended 160 gig boot primary disk, which is an SSD which I took out of the case housing of its original 2.5-inch shell and just made it strictly an edge connector, which, by the way, was pretty slick because I was able to put heat sinks on it to help extend the heat issues of SSDs so it won't be so bad. So I'm going to put the cover on here, back on it, and I'm going to then post it to my display screen, and we'll watch the post of the operating system and the boot Unix platform, as well as go into the FreeNAS TrueNAS footprint and see that did my build work out right. We will find out. So let me go ahead and put the cover on real quick, and then we'll turn around the back and power up the unit. And yes, by the way, that is a Pentium Pro dual processor compact ProLiant server. But we're not talking about that today. We're talking about this bad boy here. Alright, so stand by for just a second. I'm going to put the cover on and power up. Okay, so now we have the cover on. Now, as a side note, understand it's going to get noisy here for a pretty quick second when I power this beast up. And so I have to work around that problem. But another annoying pain in the butt about Isilon platforms is their power switch is in the back. But as you can see down here, the hookups and everything are in place, and our 10 gig pipe is over there. So I'm going to go ahead and power it up. And then you can hear it humming up, and it's getting there. Now, as another side note, the LCD display readout here is a Promca BSD based software setup. It's not practical for use in mode, and it is not functional, but you can get some basic features and functions out of the button push, but that's about it. When you're not running Isilon EMC, you're not going to get that function in place unless you write your own code in FreeBSD to make that work. So just as a heads up to you on that, here we are seeing it boot. Alright, we're starting to see all the disks. They're coming up. That's good. So the build out is good. Now, one thing with the particular HBA controller I have in this equation, which is on the motherboard, is the fact that the motherboard has to synchronize or basically serialize up the SAS disks. So as the devices are coming up, we're actually having to serialize them once, just once. After that, then the platform will actually begin the process of staging them for SAS usage. So you still have to use an isolated boot drive, not related to the SAS controller, to get this up and running because of the nature of the onboard SAS controller, and that's just how it works, to the point of the ability for the system to function. So that's why I use the SSD drive to boot it, which then we can go into the secondary mode, which is kind of a pain with SAS configuration setups in relationships to using HBA controllers as opposed to using a RAID configuration. They have their benefits, don't get me wrong, but they also have their issues, specifically as the boot post. Most platforms like Clarions and VNXs, the Fast series, they use a USB boot prom style or a localized SATA BIS card or burst card to get their systems booted up so they can get over to the SAS controllers. So, but that's what we're seeing right now here. This is FreeNAS 12.0. I will eventually flip it to TrueNAS for the SIM code level. And here we show our IP address as 174. So we'll go over here and we're going to access that platform. And this is a no-nonsense build-out. So basically, in a nutshell, you know, we're not doing anything special here. We're just basically doing a core-based boot. All right, so there is our FreeNAS, and we'll go ahead and put the baseline in. And now we're going to get the system to post. And so here we have our FreeNAS environment. Here we have our display. And this display is different, of course, depending on who and what and where. But I'm seeing my 12 processors, my 5670 platform. There's our key detail right there. The 5670s are working. They're coming up correctly. I know you don't need Windows to diagnose the state of a processor. You can use Linux platforms to do this as well. I've just slapped in a little bit of RAM, but as you can see, it's post and freed. And the pools that I built, these are HBA controller pools. These are not RAID groups. RAID groups will never show up as functional RAID groups in FreeNAS. They'll just show up as open disk space. So if you built a native RAID group, let's say a RAID 5 group of 8 2TB drives, they will only look like a single disk to FreeNAS. That's a RAID group running in native mode. This is not running native mode. Instead, this is actually just running in groups of disks that have been designated, and they have been combined together using a software stylistic RAID, in this case Z-RAID, but I still identify the RAID classifications based on their combination, sizes, and type class. So here you see a mirror reference, here you see a Z-RAID reference, and so on and so on. All these disks are single standalone disks. That's an advantage to a degree, but it also has disadvantages as well. So it's important to see that. But the most important thing about getting this dead, empty chassis NL400 was, could we rebuild it? Could we bring it back, make it better than it was as an Isilon, and make it more capable and functional? The answer is absolutely yes, we can. So with that, I end this fairly lengthy video to give you guys the opportunity to be able to do what you want to do. Anything can be built, and you can rebuild things 100 different ways. Nothing has to be definitive. I reinvented 5 of these different platforms in different formats and different layouts to accomplish what I want. And I used even older technology, or technology you may not have ever seen before, to even go even farther with this, because it's just all hardware and you can make it do all types of really great things. But for now, that's it. I'll let you guys go, and hope you had a great time. Thanks. Bye.